They don't build them like they used to.
Thank God for that. Could you imagine having a piece of underlay full of dust and dirt, pollen, dead bugs as your air filter? Give me a break. No way.
We're going to get into that. Stay tuned. All right, we're back. So two of the biggest things you want to keep in mind when you're trying to design a durable and efficient home are water management and air sealing. So starting with water management, we make a point of not saying waterproofing. Because we're not building submarines here. Water will find a way into your house, whether that's rain, melting snow, the wind can blow it in. It will find a way in. The most important thing is making sure that it has a way out and your house can dry.
But yeah, so I think that's where a lot of sort of older houses got into problems, where people were looking at it as trying to make it waterproof from the outside. But really, if you think of like vinyl siding and things like that, it's not a sealed product. It's not going to keep any kind of water, any kind of sideways rain, anything out. You really have to rely on like lapping of materials. Like, so with an overhang roof, I mean, this is the safest way to build a house. You know, modern houses and stuff look really cool, but as soon as you cut away the overhang and water can come right off the roof and drip down the whole facade, you're just looking for trouble. Like, building an overhang roof is definitely safer. You know, you've got proper eaves troughs to carry the water away, down and out.
It's an umbrella for your house, right?
Really is. And then also you have like, you know, your lap siding, flashings over windows, reverse flashings below windows and stuff. So the idea is you manage the water, you give it a path from the top all the way down, and every time it changes materials, you do a flashing so the water can come down and out. So you never want to, you incorporate rain screens and things to let the siding and everything breathe, but you really just want to keep funneling the water out of the facade. Like, you don't want it to be trapped in behind and have to find its way to the bottom, and hopefully there's a way out, which would really over time build up with debris and dirt and dust, and if you have stucco, you know, it could be full of sand and rocks and stuff. So down and out is kind of the thinking nowadays. So
all right, and number two, which doesn't get talked about nearly as much either, is vapor. So we're going to get into that. So when we talk about vapor, it's a concern everywhere. We really see the effects of it in southern Alberta here. We have extreme temperature changes, you know, within hours a lot of the time. We have extreme differences between inside and outside. Warm air wants to move to colder spaces. Warm air carries more moisture than cold air does. So we see attic rain, yeah. So you see things like attic rain. You see when you have warm air inside your house wants to move outside in the winter, it has to work its way through your wall somehow. So let's take a look at a traditional code-built wall assembly that you would see today and go through some of the pros and cons with that kind of detail.
So we're going to look at a typical wall. Not a bad drawing either, actually, by the way. So typical code-built house right now, we have, you know, drywall on the inside, 6 mil vapor barrier, not vapor retarder. This is basically a class 1 vapor barrier, so no moisture is going to move through it. Through the product itself, if there's holes and cracks and gaps and that stuff, then stuff will get through. But you know, your typical fiberglass insulation, OSB, that's kind of what it looks like in a short kind of time. And then some kind of building paper, whether it be Tyvek or Typar or black paper or something like that. So no one ever talks about air sealing and that kind of stuff. So if you drive around a construction site, you're going to see building paper going in every different direction. There's probably not taped in all the seams. Some of the seams might be taped if they're going in a vertical direction to try to keep water out again, but it's not the idea. The thinking is to keep water out, not to keep air out. So really, when you build high performance, there's a very big emphasis on air management, and having the air barrier on the outside makes the house perform better for sure.
You really have to think of air and water together, because air carries moisture.
Yeah, totally. And that gets into vapor for sure. So with your typical code-built house, the hot air, like Lachlan was saying, on the inside of your house is trying to get out. So every time, you don't think about this, but every time you hang a picture in your house or anything like that, you're actually poking through that vapor barrier. So you're actually creating places for warm, moist air inside your house to get into the wall assembly. Which again, fiberglass insulation does not do well with moisture. If you've ever seen a piece laying on the ground outside, it deteriorates pretty fast. So it's an accumulation of time, right? So moisture gets in, the fiberglass gets damp, it performs a little bit worse, so more air can get in with more moisture, makes it worse, and then your exterior cladding, or not cladding, sorry, your sheathing on the outside gets wet, it starts to deteriorate, which again in turn will let more air pass through it and stuff. So it's an accumulation of time that really makes these sort of code built wall assemblies sort of get progressively worse. And so people are starting to realize that, I think, and the thinking is changing, the code's going to change, and we're going to have to build assemblies that promote drying. And I think like the vapor barriers are a big one that is sort of not helping the situation right now.
Now, if we get into more modern, would modern be the word? A more modern wall assembly?
More high performance thinking and wall assembly, more sort of modern.
Yeah. So this would be an example. There are a million different ways to put it together, a million different products and materials you can use. Work with an energy advisor, work with people who can see problems before they happen, so you don't get yourself into a bit of a pickle with your wall not being able to dry out just because you used fancy materials or something, right? So an example, we have drywall on the inside, same as the normal one, but then we use a vapor control layer instead of a vapor barrier. This, as opposed to 6 mil poly, actually allows moisture to move through in small amounts, and it's variable. Vapor. And it's variable. So if it gets wet enough, it will allow drying to the inside of your house. We also like using products like mineral wool, where they're not affected by moisture as much. They can dry out and still retain their shape, still retain their R value, and do what they're supposed to do. On the outside, we focus on air sealing. So whether that's with something like zip sheathing that's taped and sealed everywhere, or another kind of rollout WRB, water resistive barrier, whatever it is, you can use different products. This keeps air from, this basically keeps the wind from blowing into your house. It makes a big difference, right? We can use it, depending on what you're using, it can also allow drying to the outside, or it can just completely seal everything. You just have to keep that in mind when you're designing the inside of your wall and make sure that water has a direction to go.
Yeah, you won't have potential for drying. I mean, ideally in both directions, but yeah, one way or the other, it has to have a potential to dry.
So what really helps about using vapor control instead of a vapor barrier is air transported wetting is way worse than diffusion wetting. If we're talking air transported wetting, that would be you have little holes in your assembly. You have something like this where the tie back is just lapped but not taped. There's nothing sealing it. Air can get through there, little holes here and there. It basically is a smaller surface area, so when it comes in, it can condense on the colder surface, and it's in a smaller area, so you'll have more physical water showing up.
It'll accumulate over time.
Sure. So you can have that where it's running down the inside of your vapor barrier or something like that, and collecting at the bottom of your wall and rotting out your framing. If we have a product like this is Intello Plus, it is vapor barrier variable, where if there's enough moisture in your wall, it can actually dry to the inside over the entire surface area. So you're spreading out what would be coming through a few pinholes here and there and causing problems in those select spots. You're spreading it out over the entire wall assembly, so it keeps, it basically isn't noticeable at that point. Then it's part of your interior air, it gets cycled through your mechanical systems, and it's can dry out your house that way. Moving on, let's focus on air movement in the context of indoor air quality. We talked about how it can cause a lot of problems in relation to moisture, but it can also do a lot of damage to the people living in the house, to the air quality and what you're breathing every day.
That's back to the whole houses have to breathe analogy.
We get so excited when someone says houses need to breathe. We will talk all day about it. We're going to mention a little bit here.
So typical house, if you're in a 50s bungalow, this is your house, because I live in a 50s bungalow. So we have our floor system, we have a wall, we have our lapped outside waterproofing or WRB. Sometimes there's some sort of a barrier here, poly or something. Sometimes there's nothing. And then your drywall, baseboard, and a piece of carpet.
So if you can see this right here, this is some carpet underlay. This is from a relatively new house. It is full of dust and dead bugs and nasty stuff.
And that's your air filter. That is awesome. So basically air just comes right on in under the bottom plate. Under the bottom plate by the baseboard is kind of one of the weak parts. The ceiling top corner is another really bad spot in these old houses.
Around plugs and light switches, you see a lot of that. It doesn't have to be carpet either. All of these little cracks and crannies that they just fill up with dust and grime over the years, and that's what you're breathing in every day.
When people say, Calgary's really dusty and stuff, and your house always has dust on it and stuff, it's because every time the wind blows, it's taking all the outside fresh air and blowing it right into your house. And so, your house becomes the filter for all that dust and pollen and smoke. Now we have a smoke season here in Calgary. So, there's a whole bunch of good things to do with air sealing for sure, and a lot of reasons to do it. So, what we like to do, when you get into high performance building, like I mentioned earlier about if you poke a hole to hang a picture in your vapor barrier, even on a new house, now you've introduced another hole into the wall assembly to let damp, humid air from inside your house get into the wall. So what they try to do with performance building is create a separation between any of your barriers, whether it be outside barrier or inside barrier, and like the drywall, or any potential for just less opportunity for wires to go through, and you can use this as a service cavity for running all your plugs and your pot lights in the ceiling and that kind of stuff. It just makes for a way better, makes it way easier to control all the holes you're punching in, because every time you punch a hole or someone makes a small slit or a hammer goes through or whatever it is, someone's got to fix that. And if no one does, to get into air exchanges per hour, ACH, you might have heard of that. You want that number to be as small as possible, and every pinhole or utility knife cut or whatever is going to make that hole bigger and bigger and bigger. So
absolutely, air tightness has a lot to do with your insulation value in your house. If you have a really airtight house, let's say the power goes out, your furnace dies, it's cold outside, your house is going to hold that temperature a lot longer, giving you time to figure out what's going on. The power comes back on, fix your furnace, whatever it is. If you're living in an old leaky house, that timeline is a lot shorter.
I think you get into some of these old houses that are 5 ACHs. That means in an hour, all the air in your house will be replaced 5 times. So if it's minus 30 outside, you can imagine if power goes out and your furnace stops working, how quickly your house is going to get cold. And that's literally why, because the air is just being heat. Air goes from hot to cold, and so basically all the air is leaving your house, and by default, if the air goes out, new air has to come back in. So
back to indoor air quality. If you were to build this house and put in a regular furnace and that's it, you're going to have a lot of problems. That's when people talk about having a sick house, because it's all tight and stays warm. That's great, but you have no fresh air, and that's the argument people always make. So you need to have your house built as a system. You need good air circulation. There's lots of different ways of accomplishing that, but generally HRVs and ERVs are common.
In the right way.
In the right way.
Through under the walls and through the piece of carpet fabric and stuff like that. So
So you love this one. Your house needs to breathe like a person, not like a frog. Where you're breathing through your lungs, not through your skin, right?
You want it to be through a designated path with a filtration system. So again, you're bringing in fresh air each time the furnace kicks in, or ERV or HRV kicks in, and you're getting rid of the old stale air that's in your house. So, and the benefit of these new heat recovery ventilators is that you're not just replacing all the conditioned air, whether it be warm or cold, with all the outside air. You're actually recapturing a lot of the energy you've spent to heat or cool the air in your house. So it has benefits in both directions for sure. So.
Absolutely. And you don't need to lose your connection with the outside world just because you're living in a nice, tight, cozy house. You can still open your window, let the breeze through, enjoy that a little bit. But we've all seen how bad the wildfires have gotten in the last few years. We have a smoke season in Calgary now. So when that happens, you can close your windows, you can let your proper filters in your mechanical systems do the work. You're breathing nice, clean air. If anyone in your family has allergies, when it's really bad, when there's really bad pollen outside, you can trust your filtration system to keep your air nice and clean.
Yeah.
All right, so those are some quick points for today.
Yeah.
We'll call it there. Basically, the way to look at this is that we're taking some of the good parts of really old houses where they stand for so long, they still look good 100 years later because they can breathe, like people always talk about.
It gets wet, but in the spring it dries out. So.
Exactly. So we're taking aspects of that while incorporating a focus on air quality and comfort and energy efficiency, and kind of taking the best of all of these categories to put houses together in a system so that they're comfortable and they stick around for a really long time.
And you have to look at it as a system. You can't always just, take your inefficient, leaky house and do a thermal wrap on it and expect it to be a high performance house. There's more to it than that. You really got to take like a full approach, like a full systems approach. The best way to start that is getting like an assessment done on your house. And then the assessor can check your house for air tightness. They'll give recommendations, based on your current condition. So if you're not doing like a full tear down like we've done recently and like starting over building a net zero house, if you just want to make your existing house more comfortable, more efficient, and sort of just start going down that road to net zero, getting the assessment done, building an internal team to sort of everyone helping you to get whatever your goal might be. That's definitely it. The pre-planning is definitely the way to go to get started for sure.
Totally. Yeah. And by assessment, you mean energy audit, yes. Right? So that'll be an energy advisor who can help you figure out what your house is doing now and help you make a plan moving forward. Yeah. And work with the contractor and your designers, and the whole team together can put together a proper plan so you know exactly what you're going to get.
As a system.
All right, that's all we have for today. If you've made it, it's enough. If you've made it this far, we really appreciate you tuning in. We're learning more every day. We're trying to get as much information out there as we can through these videos, through our blog, and through having conversations with people locally and from elsewhere. We're just trying to do our part to help make the industry better and to build better.
Continually building better.
Thanks for watching.
Thanks.